Welcome back to Data Explained channel, where we make complex topics easy to understand. Today we talk about data representation failures. What happens when things go wrong? Data systems rarely fail all at once. Most failures emerge gradually through drift. Representation failure occurs when data no longer faithfully reflects the reality it was intended to represent. Drift is the process by which that misalignment develops over time. Together, failure and drift describe how data systems slowly become unreliable, even when infrastructure remains stable and code does not change. Drift begins when assumptions embedded in representation stop holding. A measurement process changes, a definition evolves, a population shifts, a system begins operating under new conditions. The representation remains the same, but the reality it describes does not. This creates a gap. Early on, the gap is small, results still look reasonable. Metrics remain within expected ranges. But the representation is no longer accurate in the way it once was. There are multiple forms of drift. Data drift occurs when the statistical properties of data change. Values shift, distributions move, and frequencies evolve. The representation still works syntactically, but it no longer describes the same phenomenon. Concept drift occurs when the meaning of the data changes. Labels, categories, or outcomes no longer represent the same real-world concepts they once did. Schema drift occurs when structure changes silently. Fields gain new meanings. Units change. Optional fields become required, or vice versa. Each form of drift weakens the connection between representation and reality. Failure happens when this misalignment becomes operationally significant. Models degrade, rules misfire, thresholds no longer make sense. Decisions based on the data become systematically wrong. Importantly, representation failure is rarely dramatic. There may be no errors, no crashes, and no alerts. Systems continue to function. Data continues to flow. Outputs continue to be produced. This is what makes representation failure dangerous. The system is not broken in an obvious way. It is broken in a semantic way. Drift also accumulates. Small representational mismatches compound over time. Aggregations hide change. Historical baselines become misleading. Feedback loops reinforce outdated assumptions. In machine learning systems, this is especially pronounced. Models are trained on representations that reflect the past. As the world changes, the representations become stale, and predictions become unreliable. Detection is difficult, but essential. Drift cannot be detected by syntax alone. It requires monitoring distributions, validating assumptions, and continuously comparing representation against reality. Professional systems treat representation as a living contract. They expect drift. They measure it. They design for recalibration, retraining, and revision. Failure is not a sign that representation was wrong. It is a sign that representation was not revisited. Understanding failure and drift means understanding that data systems exist in time. Reality changes. Representation must change with it. And when it does not, failure is not sudden. It is gradual, silent, and systematic.